In this video, we'll discuss a little bit about polar graphs. In particular, we'll talk about tangents at the pole. Suppose that we have a polar graph as shown, given by the polar equation r equals f of theta. It might be helpful to be able to draw graphs if we were able to find the tangent lines at the pole. In particular, if you notice this graph, it has three leaves, so to speak. There's one leaf, two leaf, three leaf. This is a rose curve. And notice that if you draw the lines that are tangent to this graph at the pole, remember the pole is like the origin from the rectangular coordinate system. Here's a line that's tangent to the curve at the graph. Here's another line that's tangent to the curve at the graph. And then here's another line tangent to the pole at the graph. All three of these should go through the pole. Notice that for this graph, each one of these petals of the rose curve is enclosed between two tangents at the pole. So a lot of times, if you can find the tangents at the pole, then you'll be a long ways towards finding the graph of the equation. So we need that, and we could do a little bit of study, but the basic idea here is the following theorem. If f of alpha is equal to 0, that would tell us that we have a point at the pole at that particular angle, and f prime of alpha is not 0. That would tell us that the derivative of f is not 0. Then the line theta equals alpha is a tangent at the pole to the graph of r equals f of theta. So this is the theorem that's going to allow us to find tangents at the pole for various graphs, and that will help us to sketch the graph. So for instance, if we knew that we have tangents at the pole, so a quick kind of example of how we can use tangents at the pole. Alpha equals pi over 3 2 pi over 3 and pi, then we would know, and let's say that this is a rose curve, then simply drawing the tangents at the pole, there's the pole, there's the polar axis, pi over 3, let's draw the tangents at the pole in red, pi over 3 would be this line, 2 pi over 3 would be this line, and pi would be this line. So if we know we have a rose curve, then the curve will look like that curve, where those rose petals should have all the same length, and they're contained within those tangents at the pole.